Have you ever wondered why sunlight feels so warm on your skin? The answer lies in the heart of our star, the sun, where a cosmic dance of unimaginable power unfolds. Deep within its core, under crushing pressure and unimaginable heat, hydrogen atoms are forced to fuse together. This process, called nuclear fusion, is the engine that drives the sun's energy production. Imagine hydrogen atoms as tiny dancers, swirling and colliding in a fiery ballroom. The pressure is immense. The temperature a scorching 15 million degrees Celsius. These extreme conditions force the hydrogen atoms to overcome their natural repulsion and merge. This fusion creates a new element, helium, and releases an extraordinary amount of energy. This energy, born from the fusion of atoms, is what bathes our solar system in light and warmth. It takes thousands of years for this energy to travel from the sun's core to its surface. Once it reaches the surface, it bursts forth as sunlight, traveling at the speed of light to reach our planet in a mere 8 minutes. The sun's energy, a product of nuclear fusion, is the lifeblood of our solar system. It is the reason we exist, the reason for the seasons, and the reason sunlight feels so much hotter than anything else we experience. Sunlight, that golden shower that nourishes our planet, is more than just a single entity. It is a symphony of light, a spectrum of electromagnetic radiation that spans a wide range of wavelengths. This spectrum includes visible light, the colors we see in a rainbow, but it also includes invisible forms of radiation like infrared and ultraviolet light. Infrared radiation, invisible to our eyes, is what we perceive as heat. When sunlight touches your skin, it's the infrared radiation that you feel as warmth. Ultraviolet radiation, on the other hand, is responsible for tanning our skin, and in high doses can be harmful. The different wavelengths of sunlight interact with matter in unique ways. Darker colors, for instance, absorb more sunlight and therefore heat up faster than lighter colors. This is why wearing a black shirt on a sunny day will make you feel warmer than wearing a white one. Understanding the spectrum of sunlight helps us grasp its power and potential. It's not just about the light we see, it's about the invisible forces that warm our planet, drive our weather patterns, and make life on Earth possible. In our modern world, we've become accustomed to creating our own light to illuminate the night. But artificial light, whether from a light bulb or a phone screen, is but a pale imitation of the sun's powerful radiance. While artificial light sources can provide illumination, they generate heat through a less efficient process. Consider the incandescent light bulb, a staple in homes for over a century. These bulbs produce light by heating a thin filament until it glows. However, this process is remarkably inefficient. Only a small fraction of the energy used is converted into light, while the vast majority is lost as heat. In recent years, more energy-efficient lighting technologies such as LED lights have emerged. LEDs produce light through a different process that generates far less heat, making them a more sustainable and cost-effective choice. The warmth we feel from artificial light sources depends on the type of light and its proximity. A high-powered incandescent bulb held close by will feel much hotter than a distant LED light. However, even the most powerful artificial lights pale in comparison to the intense energy radiated by the sun. Section 4. Moonlight, a gentle reflection of distant energy. As the sun dips below the horizon and paints the sky with hues of orange and purple, a new light emerges: moonlight. The moon, unlike the sun, does not produce its own light. Instead, it acts as a celestial mirror, reflecting the sun's light onto our world. Moonlight, having traveled the vast distance from the sun to the moon and back again, is significantly less intense than sunlight. During its journey, some of the sun's energy is absorbed by the lunar surface. This is why moonlight has a slightly different color temperature than sunlight, often appearing cooler and bluer. Because moonlight carries far less energy than sunlight, it does not cause a noticeable increase in temperature. The perception of moonlight as cold is likely due to the contrast with the surrounding environment, which has been warmed by the sun throughout the day. Section 5. Electromagnetic radiation, the energy carrier. To truly understand the difference between sunlight, artificial light, and moonlight, we need to delve into the fundamental nature of light itself. Light, in all its forms, is a type of electromagnetic radiation. This radiation travels in waves, carrying energy across vast distances of space. The amount of energy carried by electromagnetic radiation depends on its wavelength. Shorter wavelengths, such as those of ultraviolet light, carry more energy than longer wavelengths, such as those of infrared light. When electromagnetic radiation interacts with matter, its energy can be absorbed. This absorption is what causes heating. For instance, when sunlight strikes your skin, the infrared radiation is absorbed by water molecules in your body, causing them to vibrate and generate heat. The amount of heat generated depends on the intensity of the radiation, the wavelength, and the properties of the material absorbing it. This is why different materials heat up at different rates when exposed to the same light source. Understanding the principles of electromagnetic radiation allows us to appreciate the power of the sun and the subtle beauty of moonlight. It's a reminder that the universe is full of wonders, both seen and unseen, waiting to be explored and understood.